Pascal's principle. What do we know about Pascal's principle? Pascal's principle says this. Very simply. Now, how do you translate that? The way you translate it is it doesn't matter. So we all brushed our teeth this morning, yes?
Yeah.
Excellent. Where did you press the tube? The toothpaste tube?
From the back.
Okay. What if you started pressing from the middle, or from the front, or from the middle? My kids do that, and then what they do is they twist it.
Yeah. Then you gotta go from the back.
Yeah, I know. You could do that, but the point I'm trying to make is it doesn't matter where you push it. It all comes out from the front. That's Pascal's principle.
So no matter where anything happens, it always comes.
It is uniformly distributed.
Perfect.
That's all what Pascal's principle is. Make sense? So when we talk about fluids, it doesn't matter if the fluid is compressible or incompressible. When you press on it, it gets equally distributed at all directions at the same time. Okay? Fundamentally, what does the Pascal's principle say? Let me define it formally. Pressure applied to an enclosed fluid is transmitted undiminished to every portion of the fluid and to the walls of the container. So going back to our example of a toothpaste, it doesn't matter where you apply the force, right? It gets equally transmitted, and every single time the toothpaste will come out of the same side. If you have a nick in your toothpaste, like the actual bottle, what happens if you press it? It comes out from the front as well as from that nick equally, right? It doesn't matter where that nick is. So as long as you have a container that is enclosed and you apply a pressure on it, it gets transmitted equally. So going back to your example of a balloon, if you press the balloon from one side, what happens? Does it only affect one part of the balloon, or all of the other sides of the balloon get equally enlarged? It gets transmitted equally to all the other sides if you press on one side.